Hello, my dear friends. How are you all doing today? I hope you guys are doing great. Let's solve a very interesting trigonometric integral today, which is the product of sine square and cos square x. It's a very interesting question because, first of all, there is square and there is a product. So it will be interesting to see how it gets integrated. In order to integrate this, we can do some trigonometric simplification. First of all, always remember whenever you see sine and cos together and their powers are same, we can use a formula of half angle of sine because it contains sine as well as cos together. That's the reason we can use this half angle formula to simplify this a little bit. Let's see how do we do that. So what you can do is just write that integral as so that sine square and cos square, just combine those two squares and write it as sin x times cos x square with respect to x. We use the law of exponents, and what we do is we combine those two squares into a single square for sin x and cos x. Now, if you notice that sin x and cos x or sin theta and cos theta are present together, but there is also 2 present over here. So what we can do, we can multiply and divide by 2 here in order to generate this result of half angle of sine. Okay, so what we'll get here is we'll have, let's say we have this square, which is what you see here, and then we multiply by 2 in the numerator, sin x cos x, and we divide by 2 in the denominator. Okay, now what we do is the 2 sin x cos x, 2 sin theta cos theta can be just written as sin 2 theta. So this will be nothing but sin 2x divided by 2 the whole square. Remember, we are integrating with respect to x, so we have dx over here. I hope it makes sense so far. Now it's very easy to integrate actually. What you can do here is just give the square in the numerator and the denominator. So we have integral of sine square 2x divided by 2 square is 4 with respect to x. All right. Now that 4 is a constant value can be taken out of that integral, and we'll have 1 over 4 integral of sine square 2x with respect to x. Now remember, whenever you want to integrate either sine square or cos square, we do not have the direct integral formulas for those power 2 of trigonometry. So what we do is we do power reduction identities. We use power reduction identities and convert that power 2 of sine or cos into power 1. Okay, using these identities. Okay, I hope that makes sense because these identities are converting power 2 of sine and cos into power 1. And they're also making the angle double from theta to 2 theta on the right hand side. Okay, so let's use that identity for sine square to convert that to power 2 into power 1. So we will have 1 by 4 integral of, we can say 1 minus cos of, remember that angle becomes double, okay, 2 theta. So here it is 2x. So the angle is going to become double, which is 4x divided by 2 with respect to x. Now we have converted it in a way or in a form which is easily integrable at this point. This 2 is again constant, can be taken out of the integral. So that will become 8. So 1 by 8 integral of 1 minus cos 4x is left inside. Now what we can do is, since it's a simple subtraction of integrals, we can just give that integral to both of those terms. So we will have 1 by 8 integral, let's put a bracket, integral of 1 with respect to x minus integral of cos 4x with respect to x, and let's close the bracket. I hope that makes sense. Now we know it's a very simple direct formulas of integration that we will apply. We know integral of 1 with respect to x is nothing but x. Why is that? Because we know the differentiation of x with respect to x is 1. Since integral is antiderivative, integral of 1 with respect to x is nothing but x, minus integral of cosine function is nothing but sine. But remember that this is a linear term. Instead of x, there is 4x. Okay, so we can still apply the same formula. Integral of cosine function is nothing but sine function. So sine 4x. But in integral, remember we have to divide by coefficient of x in case of linear terms. So in this case, coefficient of x is 4. So just divide by 4. Okay, it's essentially opposite of differentiation chain rule. In differentiation chain rule, we multiply by the coefficient of x, if you remember correctly. Since integral is antiderivative, we have to divide by the coefficient of x after integrating in case of the linear terms, okay? And let's close the bracket. Let's add constant of integration c, and this is nothing but your final result. I hope that makes sense. If you understand the concepts that I'm teaching, you can I request you to like this video and subscribe to this channel. Also, if you want to book a personal one-on-one tutoring with me, the website link is given in the description as well as in the comments. Don't miss it. This might be your chance to score full marks in your upcoming math and calculus exam. I'll see you tomorrow.